Thank you. So I'm going to begin with the acknowledgement of country, and then I'll introduce our speaker. So Australian-ASEAN Academics Forum Online Education during COVID-19 and beyond acknowledges the traditional owners of the land where this program was developed, the Pārawa people of the Lutruwita Nations. We pay respect to the traditional owners and to the elders past, present and emerging of the land on which the University of Tasmania campuses stand. On behalf of the University of Tasmania, we acknowledge all countries participating in this forum and also acknowledge their elders and ancestors and their legacy to us. We acknowledge the traditional owners of the lands where our partners and participants live and work across Australia and Southeast Asia. So now it's my privilege to introduce our speaker to you, and he has the terrific position of being our last speaker for the conference. So this is Dr. Ananda Maiti, who is a lecturer in Information and Communication Technology in the School of ICT at the University of Tasmania. His teaching areas include the Internet of Things, web technologies, and cloud computing. He has a deep interest in technology-enhanced learning, specifically the use of remote laboratories for various aspects of engineering education. Remote practical education requires a range of software-based services that are provided online, and this is a key area of research within e-learning. Dr. Maiti is affiliated, with the HIP Lab in Newman campus, and also undertakes human interaction research with the Australian Maritime College. I think Dr. Maiti will present his presentation, and then we will have questions at the end if that suits. And I'll pay attention to that to make sure that people get an opportunity to ask questions. So over to you, Dr. Maiti. Thank you very much.
So hi all. So we presenting this. Today I'll be discussing about the different ways we can incorporate intelligent interfaces and feedback mechanisms in online education, but I'll be specifically talking about the remote laboratory thing. So, there's obviously, nowadays we are using AI, artificial intelligence and machine learning in a lot of education-related fields as well for generating feedback that is purely online and required to be online, and which actually was a very important thing when last year due to the COVID, when we went online, we faced big problems regarding engineering or engineering style courses where people really need hands-on experience and need to deal with hardware and see things happening for their learning experiences. So the outline is, I'll be talking a little bit about the online education, specifically in context of some engineering education things, and the importance of practical education with laboratories and what is remote laboratories in general. Then I'll talk a little bit about the computational intelligence, or how the intelligence things works in an online education context. So, so engineering education in a broad terms is about like anything that is related to the engineering fields, like it could be about general physics, anything related to chemistry, mechanical, computing, electrical, architectural, and a lot of other things. So almost always involves learning a concept, like related to physics, or it could be any scientific concept. And then it is usually supported by a mathematical model. So for example, if you are learning in electrical engineering, if you are learning something like Ohm's law, you have the equation of the Ohm's law, and then you actually have to verify it by implementing a circuit and then applying voltage and then seeing it on a graph or on a device like that. So that's how typically every engineering field will work. So depending upon what field it is, it could be like a small setup on a table, or it could be a very big thing like in the surveying and all, which is done in outdoors and all. So these are that's the general characteristics of in the engineering education, specifically in these fields. So always stress on that we have to, like the student learning is finished when they can actually apply their theoretical knowledge into like a practical setup where they can show that, well, this actually works, or it, even if it doesn't work 100%, it works to a acceptable level. So that's how they learn. And this is where we, a lot of the new technology or there's a new drive to incorporate service learning within this the engineering context, is that we, it's difficult to do here in Tasmania, specifically during lockdown situations and all, but generally we try to take the students to a real world environment and try to solve a real problem. Uh, uh, Once again, it may not be 100% correct, but at least it's a workable solution. And from that, they learn all the aspects of applying any knowledge in a real world situation. So that's why the practical knowledge is very, very important in this type of education.
Excuse me for interrupting you, Dr. Mehta. I wonder, can you change your screen so that we're only seeing your
sorry.
presentation? Currently, we're seeing everything.
Right, sorry. Sorry. So I was talking about here. Okay. So yeah, so that's why the practical knowledge is very, very important on how to. Is it working correctly now, or? I suppose yeah, so that's why the practical knowledge is very important. Okay, so that's where the role of laboratories comes in. So in practical education, you have to like draw the conclusions. Like, for example, you have to generate a graph, or you have to generate some kind of mathematical model, or sometimes you actually have to calculate or recalibrate your setup according to what you see. So it's step-by-step procedures, and which involves a lot of hands-on experience. So you like put something in a bottle, and then you add some more chemicals, or you increase the voltage on an apparatus, and then you see what's happening, and then you essentially keep changing that and you keep on improving whatever you are doing, and then you keep lab notes, and then you ultimately achieving your learning outcome. So with the hands-on experience, the key things are that that we want to teach the students is about safety and also efficiency. So how quickly you can do it using the least amount of resources, or without setting things on fire and all those things. So that's part of the hands-on experience. The other key thing about laboratory education is about the collaboration of group work. So almost always in the lab, you want to work in groups, at least groups of two, and like somebody is doing it, the other one is watching and verifying whether things are working correctly or not. Also, in science education specifically, you want to verify things like whether the recorded values are all correct or not, or if you're building a circuit, then whether the wires are connected and everything all is connected correctly or not, and then we encourage students to talk to each other a lot during the laboratory activities. So what it involves is an apparatus, which is the main hardware, and then we can have, it could be like a rigid body, like a big electronic device, or it could be a flexible body setup with some wires and all those things. Some other equipment can be reconfigurable with the software or electronically, or sometimes you just have to reconfigure things mechanically with hand. So you like during experimentation, there's sometimes you have things like consumables. So specifically, if you think about chemical lab experiments, then you are always consuming the chemicals, and you have to literally throw out the chemical that has already been used or already been converted into something else. And then you have to bring in new substances for the next round of experiment with newer students. In some other kind of experiments, like the electronics ones, they are quite, there's not much of a consumable thing. So once you make the circuit, it can be reused for a lot of students. So they can just come in, change the parameters, get the reading, and then keep on doing so without actually having to reorganize anything physically. So this is included in the in a normal lab activity. So with the remote lab, what we usually do is that we just put that put all of that on the internet. So we have this setup that is already created, and that is put on the internet so that you can go to a website and you can see the apparatus through a camera, and then you can give some inputs, and then you can run the things remotely. So that's the basic essence of the remote lab. Now, there is another context, specifically in context of ICT or computation only labs, where there is no external apparatus that is used, it's all software. So, and which is, this is more important in context of, say, high-end computing resources when they're needed, like for example, in networking. So in our university, some of the networking units that we are teaching, we converted them into like remote labs during COVID, and the students essentially had managed remote desktop access to those the computers that were already in the lab, so they could then use it as if they were sitting in front of it, and then configure everything in terms of networking and all those things. The other requirements usually is when we need like more RAM or more computing resources, like the CPU power and all those things, which is typically needed in when we're teaching artificial intelligence or computer vision or anything like that. So in those cases as well, we typically will give a remote desktop access to the machines, and the students just logs in and access the content as if they were in front of the actual machine. But this remote desktop context concept usually works when it is like it's a software only thing that we are teaching in the to the students. So online laboratories are the online version of the practical experimental setup. So it is connected to the internet, and the remote labs has been around for a very long time. So the first remote labs, they appeared in early 2000s, and their main motivation was to give the resources to a lot of students. So back then, the issue the universities faced was that we had only one big setup, which was very costly back then. I mean, these days electronics are pretty cheap. So, but back in the early 2000s, even in US or in Europe, the cost of equipment was pretty high. So we only had, say, one or two equipments, and we had, say, 50 students. So it's difficult to do that in a lab. So like you can't give every student access or enough learning time to be able to access those things. So that's why that was the primary motivation, or the original motivation of going with remote labs. The online interface back then used to be quite basic. So you actually just got a screen with a camera where you can see the interface and give some very basic inputs. And so typically in the very big early stages, it was always about electronics experiment, because they were the easiest to put online. So you already had high-end equipment that were connected to the computers, and you essentially just connected them back to the web for students to access them. Some of the examples, so this is just a very few examples. There's probably hundreds of these labs developed by different universities across the world. So the iLabs was the first of its kind, and then which was started in the Maiti in United States, and then it was like in Australia, it was also built. Like the iLabs main concept was to be able to share experiments through a common web platform. So you could build an experiment anywhere. So initially it was in the US, but then in the University of Queensland, they implemented a radiation experiment and a few other experiments there, which were put through the iLabs. And then there's quite a few other experiments online from Africa and some of the African countries. And I think a lot of the latest experiments are now online from Europe as well. Then a separate project started in Europe called WebLab, which again had the same aim of putting experiments online. And then there was another similar one in RexLab in Brazil. Eventually, a lot of these actually overlapped. Like there was a federation of the remote labs started around 2015 with the Go Labs project, which was mainly initiated in Europe. And then they actually, like, the way they designed it is that if you have an experiment, then you can put it online and you can share the access to your experiment through this global platform, through the GoLabs website. There was, I put the ICES as another example. This one allowed the students to be very flexible. So the other experiments were like you get an interface like this, and you get a bunch of buttons, and you can see the graphs going up and down like that according to your experiment and like that. ICES allowed the students to like reconfigure the hardware using some electromechanical mechanisms, and then run the experiment after that. So so that's just another example. That's, like, as I said, there's a lot of examples of remote labs in various different fields across the world.
So sorry, Dr. Maiti, can you show the PowerPoint mode? It looks like you have multiple screen, right? And what we are seeing is we were seeing two things on your screens. Is that?
Oh,
look like
okay.
that's the screen for you, not for the audience.
All right.
Just make sure when we upload it on YouTube, and then it can be clearer.
Okay, let me restart the series.
So choose slideshow and please share that that's the screen with the slideshow of the PowerPoint slide.
Okay.
How many screens do you have?
Yeah, 2.
Okay, that's my guess. Yep, it's perfect.
Yeah, so
now. Thank you.
Okay.
Yep, wonderful. Thank you very much. And sorry for interrupting you.
No, that's okay. It's like I actually connected a lot of other devices earlier today. Like I changed a lot of the HDMI cables and stuff. So
Okay,
anyway.
thank you.
Okay, so yeah, so some of the key aspects that we need to address in terms of learning and teaching with remote labs is like you need to be, there should be a proper scheduling mechanism. So if normally the students is going to the lab, they are already scheduled and everybody goes into a room and then they do the experiments in the room. But after that, like if you put everything online, then we have to schedule things properly. So like students do the experiment on their own from their home or wherever, but they don't have like a coordination on who is able to access the experiments at what time. And because the experiments can have different configurations, we have to reset the experiments before somebody else can start the new experimental session. So scheduling usually manages those kind of access things. And there are different strategies. We either fix things by 1 hour time slots or 15 minutes time slots and things, or people just submit their experimental request and it is put in a queue and executed after some point of time. Student experience in this is quite affected by this one, mainly because if the experiment takes a lot of time, you usually want to put it in a queue, but if it takes a small amount of time, you want to give time slots to each student. But the length of the time slot, you have to be very careful that it's actually proportionate to what you expect the amount of time the student will need to finish the activity. If it's too small, then the students, they usually get frustrated and they can't finish it in one session, and then they have to come back and do it again at a later time. So that's the other aspects is the web interface, which will include some of the controls and a visual feedback through the camera. So at the University of Tasmania, so we have the remote lab specifically designed for embedded systems and Internet of Things applications. So this is the interface that we use at our university, is that we've got the actual devices on the left-hand side. So that's the blue color boards are what the students would actually get in the actual lab if they do it face-to-face, and then they connect it to their computers and they upload the programs and everything. But if we want to do the same thing remotely, then we have to attach some of the automation features around that, which then lets the student control the environment as if they were in front of or using the device hands-on. And then they do exactly the same activities, but they have to use a web interface through the browser to set certain parameters and alter the environment for each of the sensors on this board. Now, this is obviously one example specifically for IoT and embedded systems teaching. There can be like many different experiments like this, but they will typically have the same kind of web interface with the same kind of components here. So one of the key aspects of the remote lab or using remote labs entirely for teaching is that everything can be logged, unlike a classroom. So in a normal, if it's a face-to-face teaching in a classroom, then the students, they can do a lot of things, but we cannot log the things like we cannot, like no computing devices can log what buttons were pressed or anything like that. So it becomes a bit difficult to monitor what the student is doing. But if we do everything online, then the advantage is that every button they press or every thing they do, every parameter they change, every program they upload or everything they do is now can be recorded with time. And this actually makes the basis of bringing in the intelligence or providing intelligence services on this online platform. Some of the problems with remote labs online is that it doesn't give you much of a hands-on experience. There has been attempts to like address this issue by using virtual reality. So we had like some experiments where you put on a HMD to see a virtual reality, and then you move your hand using some kind of like the leap motion or Kinect or any other device like that, where you can alter some parts of alter things in a virtual world. But it usually will require a ubiquitous device that everybody can use, like a mobile phone or things like that. But it's still a problem. It's not a, there is no global solution for this lack of hands-on experience if we do things with the remote labs only. The other issue is the lack of collaboration. So usually when we do this kind of experiments online, we can't really expect students to form a group. They can do it, like if we ask the students to use the setup simultaneously at the same time, they can do it. But typically, when we design the learning teaching modules for the online labs, we make it as if that it has to be done by a single person only. So now the next part of the discussion is regarding the intelligent computing in education. So what can the computational intelligence do in the education field? So mainly it can adapt to the student needs. So if the student is facing difficulties, the AI can detect that and then provide more feedback, or it can like at least try to alert the tutors or the teachers that, well, this student is facing some problems in this area. It can figure out problems like common hurdles, like if the instructional, if the learning materials are not proper, or if there is something missing from there for which every student is failing to implement something, then that can be monitored as well automatically. And then obviously it can allow for 24/7 availability of support. So it's like students at the moment, if you can, if the students face some difficulty, they can always go to Google and see, well, this is the solution to their questions. So if we have the same kind of intelligent support for online laboratories, then we can say the students, if they face a difficulty, they can ask for the feedback, what to do next, and like that. So these are some of the aims of putting intelligent computing in context of any educational teaching. So in the remote labs, it can also allow for automation. So students can submit anything, and the inputs can be then automatically evaluated. So if in a normal classroom, if the tutor or whoever the teacher is can monitor the student whether they are pressing the right buttons or giving the right inputs which are safe and according to the learning objective and all those things. But if the student is doing these things alone from their home through this, when there is nobody else to watch, then we can have the AI look into the inputs that the student is giving, and then they can like it can either like say this is not a valid input, so then it can be checked, or they can give some feedback that, well, this you need to change these parameters, and then correspondingly revise the input and then execute it on the remote lab. So intelligent computing is being used in education already in context of, say, text mining, which is used to detect plagiarism and also scoring and marking a lot. So just as an example, people use Grammarly to set some parameters like who is the audience, or like the domain and the tone and all those things. And the software like Grammarly then will give a score like 93 out of 100 in this context, and then like analyze the document, which is usually an essay or like a paragraph, and then figure out its readability and the correctness of in context of grammar and everything like that. So when we talk about the remote labs, we can apply the same kind of idea there as well. So this is how AI works in general. I won't go into details of AI, obviously, but the way it works is that you use a lot of training images. I mean, if it's image processing, then you use images. If it's sound, then you will use sound files and all those things. But it involves a lot of training material, which is then used to generate a model, like using a neural network or whatever. And then when a new image is put in, then or a new item is put in, then it will be able to tell you that, well, it is a cat in this image here, but it will be able to identify or classify whatever the new image that has been put here. So we can replace this concept of images with anything that the student does in the remote lab, and then figure out whether whatever they're doing is it good or is it bad, or what should be the next change. So specifically applying this kind of concept in the remote labs, so every input is recorded digitally. So like commands, programs, and configuration setups and everything. Data is being collected real time. So whenever the student is online and they're pressing the buttons and then changing the environmental parameters or uploading their programs, everything is happening in real time. So it's like, and then, so the feedback can be generated in near real time as well. So the outputs in this context will be like or the way we can implement the AI in this context is that we can determine the absolute quality of the input for any given task. So if we are asking the students to do something like, say, turn on an LED or turn on a motor or anything like that, how good their program is to solve that problem. So we can monitor or evaluate the absolute quality of the input that is given by the students to solve this task. Or we could also monitor the students' progress with respect to time. So if they are doing the things, are they doing it in a timely manner or not? And also generate the feedback according to what the students are doing. So if we want to like evaluate an absolute quality of the students, then it's very similar to marking an exam. So we can grade whatever the students upload or do on the web interface. So the input for the AI in this context is whatever the students press, the buttons or the slider moving or anything like that. And we collect these inputs for a few semesters or like over a few years of time, and then we train the AI that is running on the server with these previously collected information. One of the limitations that is that if we use AI in this way, it limits the amount of change you can do over the year. So if we train the model on a set of activities that was done in last year, you have to use pretty much the same activities this year. So if you change the learning and teaching activity, you can't use the same AI model from last year in this year's unit. It can, but it becomes quite difficult. So the AI model that is generated will contain all possible classifications of the student input. So if the inputs is like whether it's good, bad, or anything in middle, like it's missing some components, or there is something in the input that is not supposed to be there. So all this classification can be given by the AI model. So it will work pretty much as the same as the image processing one. So we have all these training programs that has been uploaded by the student previously, and then we create the model, a new program comes in, and then the AI can say, well, the program is actually good, bad, or if it's missing something. The second one is about the monitoring the progress of the students. So if it's like it is critical that the student should be able to complete the tasks in time. So, and this is obviously very important if it is running in a single semester. So we give tasks every week and they are supposed to finish it by the next week. So if they start falling behind, then they will not be able to complete the task like 2 or 3 weeks ahead of after that. So, so the way we do it is that we set the learning goals. We divide the single week's work into separate learning goals, and we make them smaller tasks. And we set the time that, okay, this should be doable. It should be done within this time. So, and if the AI will then check the program that has been uploaded and then figure out whether the output is what should be given this specific task. So if someone is falling behind, then we can live track. I mean, we can check that in live. And if the students are not doing the right things, or if they are not uploading the right programs, then the tutors can know that pretty easily. The thing is, like, there is no restriction that the students have to do it all at the same time, like in the lab class. So they could be doing it at any time before the deadline, and then the system can automatically evaluate the performance right there. The feedback generation is the third step, which is what to tell the students. Now, this one is quite difficult to do, is that because it's easy to evaluate whether the students are doing things correctly or not, but it's very difficult to give a proper feedback to the students to ensuring that they understand things correctly. This is still a very human-oriented activity. Like if I'm teaching this thing in a class, I can understand, okay, this is what difficulty the student is facing. So I give a feedback that is very like fine-tuned to the difficulty that the student is facing. Doing that with AI, it's still a bit difficult. There are several examples like chatbots and that are usually put on websites and all, which does this kind of thing. But it's still not at a stage where it can actually cover learning and teaching. So you don't want to tell the students something that they don't understand and they are confused even more from before. So usually the strategy we can take is that we tell the students what's missing rather than trying to tell them that what to do next. And we can give this feedback directly, like saying that, okay, it's failing or it is successful, or the steps that are successful and the steps that are unsuccessful. So we can give that direct feedback, or we can give an indirect feedback where we can point out that these are the things that should not be in the inputs in the program or in the input or anything like that. And these are the things that should be in there. We can ask the students to simply check through the points whether they have included it. So the other aspects with feedback is that where to stop. So if the students are given the the opportunity to press a button and ask for feedback all the time, then they could be like just asking for the feedback, and their entire learning will be dependent on, well, how quickly they can press the button and then get the answer and then keep on doing that. So just in context of Grammarly, again, if a student is submitting an assignment and they put it on Grammarly and check the correctness of it, they can keep doing it like all the time. It's not a problem. But in context of the engineering education, where we are trying to get the students learn the physical implications of, say, turning a button on or off, we cannot, it's not a good idea to tell the students everything step by step. So the critical challenge here is that how much feedback is good and how much feedback is like giving it all away to the student. The other thing is about real-time feedback versus the on-demand feedback. So should the feedback be given automatically? So if the system detects the student input is bad, should the system be telling the students that, oh, this is bad, so you just need to improve it? Or the student should be asking, or at least they should be doing it a few times before they are allowed to see a feedback to progress further. So all of this, again, will depend largely on the activity, on the actual activity that is being done and the desired speed from the students. Like it depends on the deadline that you are giving to the students to finish the task. So if it's short, then you probably will give more on-demand feedback and real time and all that. Okay, so the instructional design for remote labs, it becomes quite challenging because it has to be fairly modular. The reason, again, is that if you make a very big task, there is a lot of different ways you can solve the problem. And if there are a lot of different ways you can solve the problem, then the AI model will have more difficulty in identifying the problem. So if we go back to this diagram here, because we are using already pre-prepared training materials like the training programs to create this model in neural network, whatever input we have given is the learning that the AI can achieve. So that's the learning rate or the quality of the learning that the AI can achieve. So if we are making, if we are giving the students a very broad objective and that can be solved in a various ways, but some of those ways were not part of the original training thing, then the AI will fail to identify whether the things are, whether the current student submission is correct or incorrect. Now, this is again a issue in specifically that I faced in the ICT areas, is that because computer programs can be written in many ways. Like it's not necessary that you cannot force the student to write a program using some specific variable names or some if-else statement or anything like that. They can write it in any way, and then it becomes quite challenging to evaluate the whole thing like that. So if we make it modular, that means that we actually we have very small tasks which ultimately add up to make a big one. Then we can evaluate the small tasks individually, which will not have much variations in how they can be solved. So the instructional design, like when you give the learning material or the tutorial contents and everything, we have to make sure that the tasks are divided and the student follow them one by one. The other issue is that it's usually single user focused. Which means that we have to schedule things properly, but we have to maintain the time gap accordingly as well. Group-based activities has been tried with remote labs. We don't try that in our university here, but some cases, like sharing the same web interface for 2 students is also possible, but it's still a bit difficulty, mainly due to network issues. If one student's network is bad, the other student is good, then they will have difficulty coordinating things. The other situation we had faced before is that one student logging in and starting the experiment while the other one doesn't show up. So if there is divided activities, then they cannot do it if it's online. However, what I noticed is that the activities do take a lot more time. So not a lot more, but at least 10 to 15% more time for the students. Like if they were able to do something in like in 1 hour, they probably take like an hour and 10 minutes or something like that, typically, sometimes more, sometimes less, but they would need more time to do the same activity on the remote labs compared to like an on-site face-to-face lab. And this is obviously due to the web interface, because they see a flat screen only, and they have to identify how to navigate and give the inputs properly instead of just using their hand to change the things which they would have done in the face-to-face one. It also is impacted by the client devices. Like if you're using like a very good setup, then it's easy. But if you are using, if the client device from where you are accessing the remote lab is not that powerful, then sometimes it creates problems. The other thing that has been critical for the remote labs is that tutorials needs to be designed containing more videos. So it's just not text. Like in a normal class, you can just give a text plus image and a lot of instructions to the students, and then you can be there to guide them. But if we are doing this in a remote lab in an online situation, then we try to give more video-based tutorials so that people can see how to, because they need to learn the interface. The web interface is also something they need to know very well. Then they can give the correct input for the experiment and then obtain the experimental results from the remote lab. So just in conclusion, so remote labs has been accessed they were originally created for simple access and control, but over time they have augmented the learning experience a lot. And in the future, they can be like supported with multiple AI tools for enhancing this individual learning or training when the students are in like isolation. So they learn things from their home, and then they like they improve on their own. So it's not like they have to go to the instructor all the time to ask the questions. They can actually get the feedback from the system itself. The other thing with this with AI tools is that it can compare multiple students performance as well. So it's not like it can look into many different students and figure out, oh, okay, these two students are doing it very nicely. So then they can compare. I mean, they don't have to tell every student that they are doing the comparison, but behind the scene, they can do the real-time comparison that the best students who are on track, who are doing everything correctly, who are getting the right output, then how do we bring the students who are falling behind up to that level? So what are they not doing, and then what should they be doing to catch up? I guess that's all for.
Lovely. Thank you very much, Dr. Maiti. That was a really very interesting presentation, and I know we had a number of people who were concerned about how to do practical classes, how to teach practical classes for once COVID-19 overtook us all and they needed to go online. So I'm sure that there will be some questions and comments about your program, about your presentation. Thank you very much. I've got a whole lot of questions myself, but I'll leave those and see whether there's somebody else here who would like to ask a question. So if you do, you could either put a note into the chat and I can call on you, or you can just jump right in and ask. Turn on your mic and ask the question of Dr. Maiti. Well, while people are thinking, perhaps I can ask a question. And so one of the things that I was interested in was the student response, how they found learning like this, particularly those who were new to this kind of approach. So could you talk a little bit about that?
I haven't actually evaluated the exact impact on the students' learning, because we have been collecting data, but normally what happens is that, I mean, pre-COVID, what used to happen is students used this when they were not in the classroom. So they still went into the classroom, And then when in the afternoon, they say, okay, I want to test out a new hypothesis or something like that. They used to do it, but their main learning and everything and assessment used to happen face to face. Now, since COVID started, we went online totally. So it's kind of like students didn't really have much of a choice other than to use it to finish their task. But as I said, like the only thing that I noticed is that they take a little bit more time. But as regarding participation, I didn't find any problems. Like every one of them were able to do the things. As well as the general feedback was pretty good. I think over 90% would have found it quite usable. But again, that depends on how well the activity is designed and how well the interface matches the experiments, the actual activities. I mean, if the activity is too complex and you don't get the inputs correctly, I mean, the interface doesn't allow the students to interface correctly, then it's a problem. Yep.
Oh, thank you. Is there anybody else with a question?
Yes, it's me, Meridian. Thank you, Monica. I think this is one of the great presentations I enjoyed from the perspective of the electronic things. Ananda, I have questions. Did you have any breakout sessions for students, or yeah? And then what's your strategy
Okay,
to
yeah.
solve
One thing.
the breakout, the breakout groups uh, works very effectively during online learning? Thank you.
Okay, yeah, that's a good point. One thing I noticed in the online learning, I'm not sure if this is just for the remote lab thing or not, but is that students are usually like, so, okay, the software that we used is the Blackboard. So so there were breakout groups, and I mean, students had the option of asking for going to breakout groups. And then in the breakout groups, we used this, we were seeing what they were doing, and then um, we instructed them to make changes and all. But the concept of remote labs is that it's not necessarily that the student have to finish everything during the 2 hours of designated tutorials. They can do everything on their own later on. And the whole idea of using the AI is that, well, you don't have to go into breakout groups. You just can do it on your own later on whenever you want to. However, one thing that I did notice is that in the online context, students sometimes were pretty shy in using, like in asking or even saying that they were facing problems. I don't know, I'm not sure, I don't know the psychology behind that, but like, that's one of the reasons I started making the video tutorials, because a lot of the students I found, like after, like this was just at the beginning of the pandemic when the lockdown started, is that I had no way to confirm whether the students were actually doing these things correctly. I mean, back then I didn't have the AI stuff or monitoring at that much. I just had the remote lab, and it was just logging everything. And I was doing a lot of these things manually in the semester 1 last year. So, so I started creating the video tutorial just to make sure that everybody, if they want to catch up, they can do it later on. But those are the issues that the AI can solve. So they don't come to the breakout group. They can or the AI can tell me, look, this person is not doing it correctly or not. So in the online interface right now, I have the access to every code that the student is uploading. I have access to the video they're saying. If it's real time, then I can see the video that they are seeing exactly. And if things break down or anything that happens, I have the record of that as well. That's the thing.
Okay, thank you. Martin Ortega, I think it was, had a question. Martin, are you there?
I see the question from Iris.
Oh, I think perhaps you could answer it from there then. Dr. Maiti, thank you.
Okay, so the question is like, is there a computer program which can help teachers understand better qualitative feedback from students. Yeah, not that I'm aware of, because most of my teaching is just computer programming. So there's not much of a software to do that. Yeah, sorry, I'm not aware.
I can answer that to a small extent, only not through my own experience, but through my, I do a lot of research applications, and there certainly are people in the analytics area who are using eye tracking with respect to student engagement and performance and so on. So there certainly are programs around, but I'm afraid that's as much as my capacity to answer that question goes. So, Irish, you had a question for Dr. Maiti? Maiti, sorry.
Good afternoon, Dr. Ananda. My question, I'm not really from the programming field. This is not really my expertise, but my interest is more on discourse analysis, like analyzing qualitative feedback, experience, etc. My question for you would be, is there a computer program or software which can help teachers understand better qualitative feedback from students, specifically about their perspectives, about the lesson, their appreciation or frustration about the course?
Not that I am aware of. But if it's just a perspective about the lessons, you could just like collect it using any online system, I suppose. Like, I don't know. I mean, if it's just a bunch of questions that you want to ask, that could be collected pretty easily. But if you want to analyze them, whether, because that goes down deep down into text mining context, like you want to determine the mood of the, like given a sentence, you can actually analyze whether the mood of the,
it's positive or negative.
Yeah, that kind of thing. Yeah, there's like a lot of Python programming that I have used in the past, which does this, but those were mainly in terms of scientific research, and they don't have really, didn't really have a good accuracy in terms of like if you, they were accurate enough for in a scientific research context, but not accurate enough if you want to apply it on your students like that. But that was, I think, 1 or 2 years back. I haven't done anything else. I'm not updated about that since then.
All right, thank you, sir. The reason why I asked that is somehow I have this hesitation about getting quantitative feedback or responses from just surveys, because what we learned from experience is that some students would just normally answer quantitative surveys, haphazardly, sometimes without even thinking, and we don't know sometimes if the results really yield genuine feedback or perspectives from our students. So that's why we wanted as much as possible to look into qualitative, but then when the feedback gets too overwhelming already, so as a teacher, we wanted supposedly to get some advice for the specific software or platform that we can use.
Yeah. I get the problem. I actually had this kind of situation in my previous university where we used to have peer feedback. So someone presented and the others were supposed to give the feedback, and that was part of the actual teaching thing, the entire curriculum thing. So they were supposed to give meaningful feedback, otherwise we cut marks. That was the thing. So, but as I said, I had written some programs myself to do some basic matching, but I couldn't at that point. This was like in 2017, 2018. So at that point, I didn't find any software that could readily do that. But yes, so but maybe there is now, because the softwares like the Grammarly, the example that I gave, is quite powerful now. So there should be something like that which can give you the mood and the depth of the. But the challenge that I did find back then was that if you want to automate these, I mean, I ultimately did everything myself. I mean, I did it manually and then I validated it with the software. So just because I don't want to rely on the software giving very bad feedback, I mean, incorrect and feedback to the students. So, but the challenge that you could face is that you have to put it in the context. So, like let's say as a student give the example of the peer feedback thing. So a student listens to another student, and then they have to give a feedback. Now, if one of the key things is that you need to, even if that feedback that was given, it has depth and it's not just a random 1-line or 2-line thing, you have to put it whether that thing is in context of the presentation or not. So if the student is talking about, say, a topic like, say making some civil engineering structures and presenting that this structure is better than that and all those things. So if that was the presentation and the peer feedback that came from the other student is that, oh, this is all good or something like that. If the context doesn't match, it's going to be difficult for you to be able to, it's going to be difficult for the teachers to understand the quality of the feedback.
Right.
You can figure out, okay, it's good or bad, whether the student is, but whether the listener actually understood or the listener actually paid attention to the finer details or not is going to be a challenge. But as I said, this was a challenge. The last time I did something like this was in 2018 or something. If you want to do it, I don't know if there's a tools like that. Once again, the issue is that you have to train if you're using AI for this kind of things, the challenge is that you have to train the model to be able to understand everything about what the student is giving the feedback about. So it's like if the student is presenting about the topic, then the AI should already know everything about the topic. Then they can give a feedback regarding the feedback given by the student. Or anything.
Thank you, Doctor.
Thank you. Very interesting discussion. So, and I think Dr. Maiti, one of the things that I took from your presentation is that you sort of had the two elements to it. One was actually the remote learning lab, and then there's the development of the AI to support your assessment and capacity to work with that. And so those two things, while they help your job, it's not necessary to actually use AI to effectively use the remote labs. Is that correct?
Yeah. I mean, the topics that I mentioned today are very relevant to the remote labs, but some of the examples, like if you're assessing something that is more theoretical or more written only, I mean, because I'm looking at a problem that is like where something that needs to be done hands-on. So those knowledge, like which button to press, which wire to connect, and like how the timing, sometimes like you have to press the buttons 1 second apart. Sometimes you have to press it 2 seconds apart. This knowledge is something you have to develop in students. So those are the things that can, come into very important in context of laboratory education. And that's where if you can implement something AI, then that can be very monitored in a very proper way.
Yeah, yes, I understand. Thank you.
But in terms of normal education, AI can be used in a lot of other contexts. I actually didn't put something in context of remote lab. There's another thing that can be done, which is my future plan. Let's go to the diagram here. So if you look at the image here, so at the moment, the student control the environment, okay? But the AI, that's another thing that the AI can do is that they can actually create environment automatically for the students. So it's like, if say, for example, this is IoT, there's a bunch of sensors here that manage the temperature, measure the temperature, the distance, and a few other things here. This is IoT, so that's why there are sensors like this. But in any kind of remote labs, the artificial intelligence could create customized situations for the students to solve given an objective. So so every student doesn't get exactly the same thing. There is a variation in how the objective is delivered or how the objective is given to the students. Now, obviously, the problem comes in is that you don't want, there should be some parity between the difficulties. Like you don't want one student to have a super difficult problem and the other student to have something easy, but you can use AI to actually create those variations and create multiple scenarios where different students will solve it slightly differently. And then they can maybe look into each other's things, but I haven't done it yet because that's too difficult. And too dangerous.
Probably more sophisticated than most of us are able to. Are there any other questions here for the about the presentation or that sort of broader issue around having the remote learning for practical subjects?
Michael would like to ask a question, and Swati also put her hand up. Michael, please go ahead.
Hello, good afternoon, Dr. Maiti. Hello, good afternoon.
Yeah.
I would like to ask a question. I've been doing research related to machine learning. So I've been looking for like the best software that I can use to analyze the data that we're gathering. So to give you a little of a context of what we're doing is we're trying to predict what are the best predictors for the success of students in a particular exam. So currently I'm considering the application Waikato Environment for Knowledge Analysis, or WIKA. So can you suggest any software which would be better or that would provide me more functionalities as to doing my analysis later on?
This scikit library from, I think the scikit, I can't remember the name now. That used to do a lot of the text mining based analysis. But yeah, I can't remember the actual. There was a Python library that I had used to analyze like the one document with another document, that kind of thing. Sorry, I mean, the thing is like my research and stuff has moved a little bit from the text-based things to a more program and hardware and those kind of things. I'm kind of not up to date with the learning and teaching that is more regarding documents and stuff like that.
Yeah, I understand, because we're also trying to like bridge the gap between what has been conducted before the pandemic and what are those outputs or inputs that we can get from the students, especially that we're integrating the online learning setup. So I think that the one that you have said about the Python environment is, I think, very useful for us, because we will, if ever, we will consider to use like the text from the qualitative assessment. So that can be something that we can, I think, use as our parameters later on. So having said that one, I think, thank you so much.
Oh yeah. Sorry.
Yeah.
I just remembered it. Sorry. It's just called SPACY, SPACY. It's a natural language processing library from Python. So you can maybe try that.
Thank you so much.
It's called SPACY.
Swasti Rulang, did you have something you wanted to ask?
Thank you. Yeah, very interesting presentation, Mr. Maiti. Do you have, or maybe you know, like a software or a computer program that can identify like cognitive load or mentally load? You said that yes, because of this pandemic, so our students have to learn online full days all of the time, and also the teacher for meeting, for teaching, and so. So if we considering about the physical fitness or psychological wellness of the students and the teachers, so I think I have to know, yes, the cognitive load of the students when they join my class, something like that. So I know that if maybe they fatigue in that class, maybe maybe from the eye blink we can identify their fatigue. What's your idea? What's your opinion?
Yeah, once again, I'm not aware of any ready-made solution. There's probably a lot of research going on around these things. The main issue with this kind of tech is the technology that you want to use. So you have to, if you are, I mean, the easiest way that I can think of is using a webcam. You ask your student to turn on their webcam, and you can, these days AI is pretty good in identifying your mental state and everything just by looking at your face. If it gets like a good view of your face, this should be, it will be able to figure out whether you are like tired or you're paying attention, or whether you are looking at somewhere else or something. Like, you don't, I mean, eye tracking is obviously a thing, the traditional way that these things have been done in the past, but I'm not sure if, I mean, it depends on how you are teaching these things, and if you're expecting the students to look at specific part of the screen all the time, then you can use eye tracking, but otherwise maybe you probably should look at more at the facial expression and stuff. So.
Yeah, the facial expressions. Yeah. So okay. So yes, thank you for the explanation.
But the problem with this kind of research, or I mean, if you're doing it as research or development, is that if you ask students to turn off their webcam, they are usually not going to. They're not very happy to do that, and you also run into a lot of ethics-related issues. Those are always a problem. That's one of the reasons that I never try to go into the details of how, like, look into more of on the student behavior and stuff like that. I only look at what they upload on the interface. How do they, everything that they do on the interface that is recorded, but that is always anonymized. So it's very easy to anonymize those kind of input to corresponding to the students and all.
Oh, okay.
So, and then the research becomes much easier, and but obviously if you want to detect the load and everything like that, then you obviously need more.
Okay, and I saw Martin comment in the chat room that he do experiment by eye tracking. So maybe Martin can add in the explanation. Thank you, Maiti.
Alexei, did you have something that you wanted to ask? No? Perhaps, Mary, do you have something now that again you want to ask? No, I can see your face, so I thought perhaps you had a question.
Sorry, are you talking to me? So no, sorry. So because my computer hung for a while, so I didn't really know if he did answer my question or not. But my question was if there are any online labs that allow for eye tracking experiments. So I'm interested in doing some advertising or marketing research with eye tracking, also for e-learning.
No, I'm not aware of any online lab that's to the, so you mean like eye tracking the students to see whether they're doing the right thing or not, or you're looking for experiment that is about the eye tracking?
Mom, did you hear that query?
So, are you looking for a remote lab that actually implements eye tracking, or you are looking for an interface that implements eye tracking?
We do sometimes have difficulty.
Anyway, I'll just answer both anyway.
With the sound and everything, so it may be that.
Yeah. Anyway,
sorry. Yeah, I had it turn it off. I didn't realize that. So sorry about that. So what I was saying is that so I don't know if you answered my question, but so my idea is that when I'm teaching, for instance, I don't know if the students are actually listening to me, are looking at the slides that I'm showing, or they're browsing other websites, right? Or just sleeping. So therefore, when I ask them to turn on the camera online with AI, I can see or determine what their eyes are doing. And based on those movements, we can tell whether they are actually concentrated on the screen or they are doing something else without me actually having to look at the 50 of them at the same time. So I thought that was a very interesting way to analyze their engagement, right? But the same type of research, I was interested in doing it for marketing and for advertising. So I was wondering if there are online labs or specific software, but online labs is much better since I can just send it to the students, where I can, get all the data from that eye tracking.
Well, the thing is that you need the device to do the tracking, right?
Well, that would be the webcams, right? Pretty much every computer or phone they use, it has a cam on it.
Yeah, I mean, I'm aware of some research in this that has been done, but I don't know if there's any commercial product available that you can just start using.
Yeah, well, the commercial products, I do know them, but I was thinking on the free labs online, right? Since my unit cannot really pay for the commercial software.
Yeah. No, I'm not aware of anything that you can just start using off the shelf. Although I'm not sure, shouldn't be that difficult to make one, because these days browser-based JavaScript libraries for AI are pretty strong, and browsers can take the camera image using web toolkits and everything like that. So you may be able to find some examples. I mean, I haven't searched for them before, so I'm not aware of anything specific. I should be able to find something.
Okay, thank you.
But yeah, so just out of curiosity, how many students do you actually get in a classroom? I mean, when you are lecturing?
For me, somewhere between 35 and 50. It depends.
Okay, that's pretty good. Because I don't know about people in UDAS, but I think within ICT, it's pretty usually the first 2 weeks people actually show up, and after that they just don't show up during the lecture. It's always a recorded lecture, and they then hear it back, and then we don't have attendance, like mandatory attendance or something like that.
Okay, Ruby, I can see that you've got your camera on. Did you have another question to ask? No? Okay. One of the things, Dr. Maiti, that I was really interested in was the issue around the sharing of devices. You talked about the global platforms and how people can use some of those and contribute to some of those. That seems like such a wonderful idea for other areas as well, who are people who are creating these kinds of online practical labs. So I thought that was a really interesting.
Yeah, so it's initially, obviously, everything. Okay, one of the problems with remote labs is that they are low maintenance, but they still require some maintenance and needs to be built by some expertise. Like you need to have expertise to actually build it and then keep it going all the time. And it varies. So every university, if it's in physics or whatever, they know what they are building and how to keep it operating. So from the beginning, the tradition was that every university, what they are teaching, they just build the stuff for their student. Then I think around 2010s, the first attempt I think was made through a system called LILA, the Library of Labs, again in Europe. Because the thing is, in Europe, pretty much every big universities has these remote labs, and so they started to combine the things and started to share the things. So the experiments were still hosted by one university, but students from another university could just log in and access it remotely. So that was the idea. And then I think in 2015, the Go Labs initiative was started. So that was that we take this to the school level. So the same setup and everything, but we altered the learning materials to make it more more suitable towards school children and all. So that way they were promoting the STEM learning and teaching through that. And again, the idea was the same thing, that we bring in every experiment from in the world, and as long as it has a web page and can be authenticated, we just put it connected to their interface and like that. However, one trend that did happen, unfortunately, because before COVID, a lot of the remote labs, I think, this is just my personal opinion, I haven't actually looked into the real world thing, but before that, a lot of the remote labs were quite openly accessible. It's like anybody can go, because they were not the main thing, like they were just additional thing that a student could do. After that, I think a lot of universities imposed some kind of limits, because they were the only way the students could do the engineering learning and teaching. So universities just were like restricting them to their specific users and all those things. So hopefully once this is over, it will go back to, or the other way is to scale it up, is that we have like the image that I showed up, like I have got 12 setups of the similar setups, so the student can do it. If I have 24, 30 or 50, then I could obviously share that with a lot of other people in the world and they can use it.
Yes, I thought it was a very generous activity, but I did wonder about the commercial aspects and how, that I could see universities going, oh, but we've created that, we can't just let it go for free. So.
Yeah, that's the thing. So, I mean, if it's one or two, people can give it for free, but if it becomes a large scale thing, and then, because these machines that I showed, they are meant to be running online and they do run quite well for a semester. But after that, usually the camera falls down. They just, there's some issues that it has to be maintained. But at least from my experience in our university, because of the Australian border lockdown, a lot of my students were stuck in China, or overseas, so they couldn't come here. So this was the only way they could actually finish the course. Otherwise, they had to have to. I don't know how they would have done it, but otherwise I would have. The way it happened in the engineering, I'm not sure about how they did it in the School of Engineering in our university. I think they have some remote access stuff, but a lot of their, because of the time limit, they had to change the assignments a lot to more written only things and stuff like that during the COVID. But
So do we have any final questions for Dr. Maiti? I think not. So let me just say then, thank you very much for the presentation. It was really very interesting, and I'm sure there will be many things that spin off in people's minds about what they might do in their classes from your presentation. So thank you very much. And thank you to all of you who have participated, both today, but also, of course, across the entire conference. It's been fascinating for me time, such interesting presentations, such interesting questions, and clearly addressing such a significant topic for us all at the moment. So thank you all. We look forward to talking to you over the next couple of weeks about your experiences and what you're doing, and look forward to seeing you again in September, I think, so in small groups initially, and then at the second round of our conference in September. So thank you all very much. See you again. Goodbye.
Goodbye, everyone. Goodbye.
Thank you. Goodbye, everyone. Thank you. See you next week for the interviews. We look forward to hearing your reactions. Thank you. We will send you the information soon. Thank you very much. Bye-bye.